Welcome to our PyLadies London meetup. For those who don't know me yet, my name is Anna. I'm one of the organizers of PyLadies London, and I just wanted to make you aware of a few things. For those of you who don't know yet, EuroPython is coming to Dublin, which is really a short flight from London. It's happening on the 11th to 17th July in Dublin. And I know the PyLadies Dublin, the Django Girls Dublin, they're planning for a lot of fun events around this event. So I won't be able to make it sadly this year because my sister is getting married and that has priority. But if you can make it, I highly recommend testing it out. Even if it's your first conference, it's a good chance to connect with the Python community and meet other people. Then I wanted to tell you about tupu.io. It is a platform built by two good friends of mine that I also happen to work with in my previous job. And what they do is mentorship in tech. I have mentors. They have helped me a lot for career growth, for financial stuff, for personal stuff. So it's been really helpful to have someone that I can talk to. And I also mentor someone via Tupu. So if you're interested in either taking on a mentee or being mentored by someone sign up through tupu.io. It's a free service. They will pair you up with someone and just test it out, spread the word. It's a great opportunity. And then I just announced our meetup for May. We will have a talk on blockchain, which I'm pretty excited about because it's something I don't know much about, blockchain and Python. So make sure you sign up and you join us for our meetup on 17th May at 6 p.m. On Python and blockchain. But that's it from me. And now I will head over to the wonderful Evgeniya, who will present on Crowdkit.
Thank you very much, Anna. Okay, let me share and let me start. Okay, I guess everybody sees what everybody should see.
Yes.
Oh, perfect. Okay, so my name is Evgeniya Sukhodolskaya, or Jenny, and I'm Data Evangelist at Toloka. Also worked as a machine learning engineer, as a software developer in Python. And I would like to talk to you ladies today about the Crowdkit, which is a library for a crowdsourced annotations aggregation, which is in a way similar to Scikit-Learn. So what are we talking about today? I will try firstly explain what are the crowdsourced annotations and why we even need a library for them. So give a short overview. Then I'll try to explain why I dragged in a Scikit-Learn, such very enormous and very well-known library, to my small talk. And I will give a quick recap because I can understand that there are people from different fields and maybe somebody doesn't really well acquired with a Scikit-Learn. I will finally present our Crowdkit and give a short demonstration to explain how to use this library. So let's begin. Let's start with crowdsourced annotations and what are they, what I am talking about here. So let's imagine you have a problem. You have a problem, you need to gather a data set of some annotations, which could be from every field. For example, you have a task, like such a normal task as training a self-driving car, and you need to find the data set of the pictures where the segmentations on pictures showing the signs. Or for example, you're developing a moderation algorithm, you have your app, you have some users commenting in the App Store, for example, and they're commenting differently. Sometimes it's gibberish, sometimes it's really sensible information, sometimes it's hate speech. People can be different in expressing their emotions, and you want to understand what is actually valuable and requires the instant attention, and what is can be solved automatically. And of course, if you're starting with a small problem, you can gather a data set yourself. You take some data, find it on the internet, maybe take pictures, evaluate them, annotate them, boom, you have a result. But the usually problem is when you need a data set for some serious task, like for example, training a machine learning algorithm, you need a big one. And when you need a big one, here comes the crowd. So usually crowdsourcing is the conception when I have like a task, for example, like annotating some data set or gathering some data, and you break it in a small pieces, more understandable pieces. For example, like in a classification task, it could be like find an image is like image depicting like a cat or a dog, classical hello world problem of the crowdsourced annotation. And you give it to performers, which are like all over the world, people of different education and everything. And for some fixed price, which is usually not very high, they're annotating your data. And you can annotate huge amounts of data with that. But if you're like starting from the beginning, yeah, the amount is easy to get, but how to get the quality? And the first and the easiest trick comes from the very well-known phrase that the two heads better than the one. We're using an overlap in crowdsourced annotations. Basically, you're having an object, for example, a picture, and you want like find some classification of it, or maybe some segmentation of it, or like is it a text or something else, and you're giving this object to a different people from the crowd, for example, like 3 of them or 5 of them, and you receive like more results, and like seeing how people react, how people annotate it, you can understand how they are like basically the general idea of it. And so what is more correct answer in this? And of course, when you like receive these multiple answers for your object, you want like one concrete label, one like specific answer for your problem. What is that? And here comes the aggregation. But how to aggregate crowdsourced annotations? Okay, let's consider we have a classification problem. Classification problem should be easy. For example, you have like, as I said, picture, cat or a dog, and you receive some answers, for example, from 3 people. The most like easy way to find an aggregated answer would be a majority rule. I think it's like pretty easy to understand. You have like 2 people who think that's a cat, 1 person who thinks that's a dog. You're thinking, okay, 2 people are like more right than 1. That's a cat. Everything is solved. Okay, let's dig in a little bit deeper. For example, you know somehow beforehand that some people are more professional in the certain task that you're giving them to. For example, you can estimate their reliability, and you know that like performer 3 performs like way different than performer 1 and 2. Then somehow you want to account their reliability in the overall aggregation process. Okay, then you have like your estimated qualities of your workers, and you're like doing a weighted majority vote. Okay, the result is still pretty much similar, and I think like every Python user can like in one liner implement this majority vote and so have like 0 struggle. Okay, so why do we need any like aggregations library and everything? Let's come to that. We have other types of data, and we need to aggregate them also. For example, you have a problem when you need to gather like some textual responses, for example, description of a picture, or you have a segmentations problem and they are receiving like traffic lights. You're receiving bounding boxes for traffic lights, and they are slightly different, but they are correct, but still you need one aggregation. Or you have pairwise comparisons, which are like basically you need to create a ranking problem, which are like search engines, for example, are dealing with. Then it comes to a thought that you need to invest a lot of work in creating these aggregation methods. And here comes the Crowdkit. The Crowdkit is a library built for crowdsourced aggregations. It has a lot of the methods which can be used for aggregating and using it for crowdsourced annotations. It's available since it may be used with a Python 3.7 plus, and it was created in a way to be like very understandable for the people who usually work with machine learning or data science, because these people usually know the ecosystem of NumPy, SciPy, Pandas, etc., and specifically Scikit-Learn. And Crowdkit was built in the same idea. So the person who knows this ecosystem would easily dive in the crowdsourced annotations without any headbang. So why I am always like referring to Scikit-Learn in connection with the Crowdkit? I would say the main idea was to build Crowdkit on the same principles as the Scikit-Learn was built. So it's 4 principles. It's consistency, inspection, non-proliferation of classes, and sensible defaults. And let me explain a bit each of them. So consistency, it's like each interface implemented is consistent in a way like it has a limited amount of methods implemented in and it's consistent. Inspection, that we have constructor variables and variables which are acquired in the learning process, which we're talking about machine learning or like learning the aggregation in Crowdkit. They're exploited as a public attributes to the user. Non-proliferation of classes, it's about that only the specific algorithms which related to the specificity of the libraries, which is like aggregation method or the machine learning method. They are custom classes, but the rest, the data is like a well-known data types, which is like NumPy, SciPy, vectors, or maybe just strings, etc. And sensible defaults, it's about like, usually in this library, we use predefined variables. For example, like some methods require user definition, hyperparameter definition for creating some specific learning algorithm. But in Scikit-Learn, and we tried to recreate it in Crowdkit, we provide defaults, which will be when you'll be using the algorithms, which will perform not worse than if you like it will, they will perform moderately good. That's what I would like to say. So yeah, and also of course we use the same duck typing principle, but I mean Python and duck typing are kind of very well connected, I would say. And I really want to do a quick recap of Scikit-Learn to dive in more in why Crowdkit and Scikit-Learn can be easily used together, because they're built on the same, I would say, structure, and they look alike in some way. So Scikit-Learn, it's a machine learning library which implements some famous classical machine learning algorithms, and also some metrics and some toy data sets also related to them. And it has 3 major interfaces, which are estimator, predictor, and transformer. Estimator, it's like the main feature of it is the conception of it is similar to partial function application, as you can see here on the picture. So the learning process of your algorithm, which is like created from an estimator object, and the predefinition of it, they're decoupled. So firstly, you defined an object estimator with some hyperparameters, and then you can insert your custom data, different one, some samples, for example, your learning algorithm of classification, I don't know, like spam letters. And so you firstly defined your algorithm, which is like with some parameters, and then you can induce some different data from the spam, and you can use this object multiple times. So this is the concept of the partial function application. So estimator is responsible for learning algorithms. They acquire some structure from data which you provided, and then you can use this information to see some hidden patterns.
Ale przy okazji padło mi do głowy, że przecież na naszych mega retrospektywach może być ten sam problem. I wybór narzędzia jest bardzo istotny, by każdy mógł na różnych urządzeniach. Dokładnie tak.
I'm deeply sorry, what's happening?
Sorry, I muted the person.
Yeah, you muted firstly me.
Sorry.
It's okay, it's okay. Okay, that was my refreshment. Okay, so where did I stop? Okay, so yeah, estimator is responsible for learning. So you acquire some hidden patterns in the data, you store it in an object, you can use more data to learn it more. And this is like the first part. The second part is predictor. It's an extended interface of the estimator, which also predicts on a data. Predicts, I mean, in a way that you have like, you learned on some data, some like hidden differences, some hidden, patterns. And now you have like new unseen data and you are predicting some labels for it. So for example, for classification problem, you learn that these texts look like spam texts, you see new data, you predict, okay, this text is spam, this text is not spam. And for unsupervised problems, it's when we don't have like predefined labels, which we can learn on. For example, clustering problems, when we see like different data and we cluster it by some like special, I don't know, features which look alike. It predicts also on the new unseen projects, which like cluster they belong to. And transformers are also like, they are responsible for transforming data, for learning, like changing its appearance in some way. Okay, so we have these three main interfaces. And these three main interfaces have these methods, which are really, really well known, I guess, in the data science world. It's like fit for estimator. Fit is basically learning. For predictor, it unsurprisingly predict, and also predict probability, which is returns for some algorithms how we sure about the predicted value. And some predictors can also do the same operation of fitting and predicting at the same time, usually unsupervised ones. And also transformers do transform and fit transform, which is like also unsurprising from the name. Okay, so we have these three major interfaces. We have these methods which are implement learning and predicting the new information. And let's talk also about the inputs. So machine learning algorithms like usually operate on the matrix data. So you can imagine we have like some samples, they have some features. So one sample can be like one image, like described in some way. For example, one image which has like 5 cats and 6 dogs, and so 5 cats and 6 dogs, it's description of this image, so it is its features. And like another image which has like different amounts. So we have like samples and their description features, and each algorithm works on, should work at least, badly or not badly, but in some way, on a different amount of samples and different amount of features. So we are not bounding, not by the amount of columns, not by the amount of rows. So in a way, the most efficient way to use as an input the structure would be using the NumPy vectorized operations and the NumPy vectors, also SciPy, and also we can use a pandas data frames. So we're working here with matrices, and let's remember about it. Okay. And here you can see example. I'm just showing how it's like generally looks like. So we have Scikit-Learn, we have some data, and we need to fit a regression, like a linear regression on it. Basically, if you can see, we are provided with these dots, which are data, and we are trying to find a function which like tries to capture the structure of these dots, their correlation in the most like efficient way. And it's pretty much easy. Even the people who never like seen Scikit-Learn in their life, you just importing this linear model, you're taking some data from the toy data sets, and you're basically calling linear regression model, you're fitting on the data, and you're predicting on the unseen new data, which is like test data. So it's pretty similar, pretty simple, I'm sorry. Okay. So after we looked a little bit what is Scikit-Learn is, we can now see and compare and explore what the Crowdkit is and how they like relate in a way, how they can be used together. So in Crowdkit, we have this situation. In crowdsourced annotations, it's more important to look at the type of the data that you aggregate, because the methods which are applied for aggregation really depend on the data type. It's on text you use once, on the classification you use another methods, and they are not interchangeable. That was the decision to implement 5 interfaces by the main data types used for aggregation, but they use the same, and they use and implement the same methods that Scikit-Learn uses. It's fit, predict, and predict probability. In a way, I would say each of the interfaces here is a predictor in a Scikit-Learn, because crowdsourced annotations, in a way, they're like unsupervised machine learning algorithms. You don't have the predefined labels, you just have the results from the crowd, and you need to aggregate them somehow. Okay, what is also the similarity and differences with the Scikit-Learn? Okay, so we also try to use simplest data structures well known by a data science crowd, but the problem, or not a problem, I would say a feature of the crowdsourced annotations is that, yeah, you can like aggregate as many samples as you can. As you remember, I said about the matrix data, the samples and the features. So yeah, you can aggregate as many samples as you want to, but the features amount always limited. We always need to know what are the labels, who labeled these labels, like which worker did which labeling, because we're also sometimes relying on their skills. So it's important to distinguish, and we need to know which task we receive the label to, because it's really important to know like which object relates to which label. Okay, so talking about the inputs in the Crowdkit. It's in a way simple to a Scikit-Learn, but we have a little bit differences here. So the difference is in that situation that we have also the matrix data, and we can aggregate as much samples as we want to, but the amount of features that we are like using here with the crowdsourced aggregations are bounded, because in machine learning you can learn like with 1 feature or 100, but in crowdsourced annotations you really should know about the label, who labeled the tasks, the worker, because you really need to know like which worker with which skill, which quality did the labeling, and you need to know the task ID, because usually you would like to know which object received which labels by which workers. So that's why we decided to use pandas data frames, because we can use 3 named columns, label, worker, and task, and add some additional ones, for example, like weights, or like do not add them for like weighted majority vote. But the amount of rows is of course unbounded. So yeah, it's in a way the same matrix implementation, but yeah, a little bit more complicated. Okay, so let's talk, what do we have here? We have such an aggregation methods implemented in a Crowdkit. We have them divided by the types of the data that we are using, and it's categorical responses, which is classification, textual responses, image segmentation, and pairwise comparisons. They are the methods which you can see here. They're like differ in a way of like complexity, or like they're more dependent on some certain tasks, or like certain availability of the data, of the ground truth labels, of the like worker skills, etc. But they all can be used in some way, and if like we'll have some time, we can talk about them in particular. Okay, also Crowdkit provides datasets, which are not even toy datasets, that's actually serious one, crowdsourced datasets, which were created by one of the crowdsourcing platforms. And you can see here the names of them. You can like look after like the Crowdkit is an open source library. You can look after my talk and like try to see some data. And they're pretty interesting to play with, such in machine learning setting and also in aggregation setting. And also Crowdkit implements some metrics on the aggregations, for example, the metrics on workers, which is accuracy on aggregates. So it computes the amount of the answers the workers did agreed with the majority, and it implements the data metrics. For example, the posterior labels, considering the skills of the workers. It's Alpa, Krippendorf, and the others ones. So you can also apply them, use them, and see like how your aggregations are succeeding and how your labels are pretty close to a nice use. And let's have a little demonstration. But before having a little demonstration, let me like shortly explain what I will demonstrate to you. So I will talk about the David-skin aggregation, which is like a little bit, I would say, more complex than majority vote. That's why I want to compare it in the demonstration for you. And it's to understanding it, basically, we need to remember two concepts. It's a confusion matrix, which is written incorrectly on slide, and the idea of expectation maximization algorithm. So confusion matrix, what is that? So this is a categorical problem setting. Let's imagine we have some algorithm or we have some workers. It can be in machine learning, it can be in a crowdsourcing setting. So some black box which predicts class. For example, we have a multi-class program and we're classifying apple, oranges, and mangoes. So we have predicted class and we have some knowledge about the true class. And here you can see, for example, if we're looking at the highest row, our algorithm predicted apple 7 times and it was correct. Our algorithm predicted apple 8 times, but it was orange. Our algorithm predicted apple 9 times, but it was mango. So that's the way to read this confusion matrix. And David-skin aggregation uses this confusion matrices. But here, as algorithm, it uses workers, and as a true class, it uses some conception of like expectation maximization algorithm, where we think that we know true class. And the expectation maximization algorithm is basically about that you're having some latent variable, which you don't know, which is like true label in an unsupervised setting. In supervised setting, you would be provided with it, but in a supervised setting, you don't know the true label. So you're guessing what is like more likely to have it. So you're guessing the true label, and then considering that you guessed correctly on this iteration, you're like plugging it in, you're like adapting your algorithm to these true labels, which are like we guessed. And there you are doing this iteration again and again till your algorithm on your expected true classes starts working perfectly. So it converges. So yeah, here we can see basically the setting. So we have like some classes priors, which we usually select by the majority, the classes priors we select usually by just like looking at the answers of the workers. So we receive some answers and we just see, okay, the class 5 was selected 1,000 times and the class like 4 was selected 2,000 times. So receiving class 4 is more probable. And we have here a confusion matrix, which I showed on the slide before. And we basically doing iterations where we firstly, on the 0 iteration by majority vote, we're deciding that we're thinking by majority vote that the true labels is what the majority vote shows. And then we're like calculating the confusion matrix based on it. And then we're plugging it in, we're adapting our like aggregation in the best way possible to this confusion matrix. We're guessing a new true labels based on it, and we are doing it till we have like some desired quality. Okay, and now I think I can give you like a small demonstration. Let me reshare. Okay. And we are sharing our demonstration. Okay. So We're firstly installing the library, which is like pip install Crowdkit, which should be pretty simple. And then we are loading dataset relevance 2, which is from the datasets that I showed, crowdsourcing datasets. This one is about showing, like estimating the relevance of the document showed by a search engine and the search query. So for example, you're Googling, okay, weather in Munich. I'm living currently in Munich, and you like see like some weather in Munich, and then like some weather around the world, then something about the Munich, and you're thinking how relevant the results are to this query. So we are loading here the main crowdsourced results, and we are storing them in data frame, and we are loading provided ground truth labels, which are we will use for the estimation of the quality of our aggregations. They are not like the 100% of them. Usually we can like gather like 10% of them with the experts. Okay, so let's look at the crowdsourced data. It looks like this. We have like some workers, we have some tasks, and they provide some labels. We can see how much overlap we used this, so how many workers were labeling the same task. And it's about 4. Okay. So, and let's firstly look at the ground truth labels. So the ground truth labels are here. And yeah, as I said, the percentage usually of the ground truth labels available is about like 10. It's more easy to gather like a small amount of them and like try to adjust our algorithms and our crowdsourcing on this like small amount of ground truth labels. Okay, so let's compare our methods, majority vote and David Skin. We're just importing these 2 methods from Crowdkit aggregation, and we're doing the simplest thing, one-liner. So we're just instantiating the object of the majority vote aggregation and David Skin aggregation, and we're fitting, and at the same time, we're predicting our aggregations. Let's do it. And let's then look at them. So look what our algorithms, our aggregation algorithms return for our workers. So for majority vote, we see these results. And for the David Skin, we see a little bit, slightly bit different results. So David Skin tried to also see more precisely how the workers are like conducting the tasks in general. Okay, so let's see, let's evaluate. We're using the simple metrics for the classification, which is F1 score. It can be used, usually it's used for binary classification, but Scikit-Learn provides it also for multi-classification. It's just weights each class based on the amount of values of each class, the amount of the values in each class presented. So yeah, but here we have a binary classification problem. So let's see, okay, on the majority vote, we received that the quality of our, the quality of our crowdsourced annotations gathered is about 77%. But let's look how good aggregation of the David Skin performed. And it's a little bit, okay, I would say 3% is not a little bit, it's better. It's better, so not only it's important to gather a really good performing crowd and train it in some way, but also it's very important to aggregate it smartly. And we can simply receive our aggregated result, which is here, and use it for our machine learning algorithm, etc. Okay, so that's it for my really short demonstration. And let's return to our presentation. And basically, I would say that's it. And let me provide you with a little bit of links, which I will give away on the demand. It's basically a little article about the Crowdkit documentation, link to the GitHub with implementation, which is open source, and you can add your comments or request some features, and a little bit of the examples. So thank you very much.
Thank you for the great presentation, and sorry about the distractions. Thank you for handling that so well. If you can send me the links, I will send them out to everyone after this talk. Also, the video will be sent out to everyone as well. Do we have questions right now? Sophia is saying it's my first time using a Crowdkit, so everything is new to me. Good presentation. Thanks. That's very nice feedback, Sophia. Any questions we have? If you don't, you can also see Evgeniya's email address on the
Yeah, I would be happy to answer any questions, always.
Okay. If we don't have any questions, oh, there is. Magdalena says, the algorithms that are in Crowdkit, some of them look pretty complex. In your opinion, as a user, I need to really understand them to be able to use them for my own problem. So the question is, do you need to understand the algorithms in the Crowdkit in order to use them?
I would say, of course, like in any problem, for example, in like machine learning setting, it's better to know what are you using. But in the simple settings, you can use it just as a black box, because in the documentation, the recommendations provided for certain types of data. So you just need to understand, like, I have these types of data, I have this problem, is it like categorical, or it's like with text or with images, which amount of data I have, do I know something about the quality of the crowdsourcing project, and then you, based on the recommendations, use the method provided, and it's enough. It's enough for some decent result. Thank you very much for the question, by the way.
Tanya says, thank you for the great talk. Thank you, Tanya. And then Mary asks, how many contributions from users do you need to make this work?
I would say, okay, so we're talking about the contributions of the crowdsourcing workers, or we are talking about something different? Because, crowdsourcing workers. Okay, I would say, if we're talking about the overlap, so I would say the main value which is used usually is like overlap of 3, but it depends very much on the complexity of the problem, the type of the problem, the amount of money that you're willing to spend, the control quality rules that you're using, and etc., etc., etc. So I would say it's like really difficult to answer, because crowd science, in a way, it's a science, but I would say like 3 is a like really good base number.
Okay, great. We don't have any other questions. So thank you again for the great presentation. I hope you all have a nice evening, and I'll see you in the next meetup. And I'll follow up with you, Evgeniya and Valentina, via email. So thank you. Enjoy the evening. Take care, everyone. Bye.
Thank you very much.